The first question asks that we identify on the map the highest and lowest points and what caused those features. I identified those points from left to right, beginning with Eastern Africa, which was caused by the East African Rift and erupting magma chambers that have formed below. Second, Europe and East Asian mountains formed as a result of convergent plate boundaries, including continental collisions. Third, the west coast of North America that was formed as a result of subduction at oceanic continental plate boundaries. And fourth, the west coast of South America that was also formed as a result of subduction at oceanic continental plate boundaries. The second question asks, which portions of the map contain the youngest and oldest crust? And explain your answer. I wrote as far as the oldest oceanic crust and the youngest, that the youngest occurs at the Pacific Ring of Fire because subduction is occurring on both sides of the Pacific Ocean. The oldest crust lies on the coast of Eastern Africa, Western Australia, eastern coast of the Americas, and west coast of Europe due to divergent plate boundaries. And then I put for the oldest continental crust, Australia, which was confirmed via radioactive testing. The third question asks, how does the theory of plate tectonics explain the location of earthquakes and volcanoes, and where do most earthquakes and volcanoes occur? I wrote that plate tectonics move due to driving and resisting forces. As a result, they are located along plate boundaries, which map the majority of all volcanic and earthquake activity. So they follow each other. For the fourth question, you asked for us to identify examples in a map where earthquakes and volcanoes occur in the interior of plates and what might cause those earthquakes and volcanoes in the plate interiors. I first wrote for earthquakes that occur in California's interior off the coast are the result of transform faults formed by the subduction of an oceanic continental convergent plate boundary. And volcanoes occur in Africa's interior due to hotspots created as a result of divergent plate boundaries.